Hello students, and today I am taking the question number 8 to 15, that I will try that up to 15 question must be solved. This is the series H1 of NEET-2019 which was held for the second time in 2019. You watch the video completely so that you could understand the question. So this is from question number 8 to 15. Now question number 8 is the circuit diagram shown here. Corresponds to the logic gate. Here this is the this is A, this is B, and here this is giving the resistance. This is now plus 6 volt. This is now resistance R, and here we have a LED bulb. And then this is now 0, this is 1, this is 0, this is 1. This is given the circuit, and the options are given here. First is none. Second is nor. Third is and fourth is or. Now for the answer to this question, you are given the inputs A and B, and you see that here this is a resistance also here on this side. This is also the resistance R. So now let us make the truth table, then we can find that which gate it corresponds. This is now A, this is B, and this is now Y. So when this is now suppose 0 and 0, means both are open, then current will go through this LED. This is now LED bulb. LED will glow. So this is now 1. Then this 0 and 1. This is now 0. This is open. This is now closed. So the current will pass through this here, and current will not go in the LED bulb. So LED bulb will not glow. Will not glow means this is now your 0. This is 1 and 0. The current will pass through this A and goes directly to the earth. LED bulb will not glow. It means that this is now equal to 0, 1 and 1. When both are closed, the current will pass through them and go to the earth, so LED bulb will not glow. This is now 0. Now we have to correspond to all these. This is not the AND gate or NOR gate. You can see that if we multiply then 0, 0, this must be 0, so this is not 0, this is now 1. It means that AND gate and OR gate are not the options. Our option is either AND gate or NOR gate. So what we first, let us multiply 0, 0 into this is now 0, and we take the reverse of it, then this must be 1. This is now 0, then 0, that must be now 1, but this is now 0. This is now 0. When we multiply, this is now 0, 0 should be here the 1. So this does not correspond to the AND gate. Now we take the OR gate, we add them. This is now 0, 0, then NOR will be 1. This is now 1, NOR will be 0. This is now 1, NOR will be 0. This is 1, and then NOR will be 0. So our right option is what? The second. So our answer corresponds to now second option. So in case of logic gates, what you see, first you find that what the truth table, and then make it comparable with all these gates. Remember that the current will not pass through the resistance when these are taken to be 1 and 1, or these are the closed, because this is a short circuit and current directly pass through this one. When the current passes like this, then the bulb will grow. So that will be equal to 1. So this is our right answer to this question. And now question number 9. Value of gamma. Value of gamma equal to Cp upon Cv. For hydrogen, helium, helium, and another ideal diatomic gas, and another ideal diatomic gas X. This is given now X, whose molecules are not rigid. Whose molecules are not rigid, but have an additional vibrational mode. Are respectively equal to. Now option is, first is your 7 by 5, 5 by 3, and 7 by 5. Second option, 7 by 5, 5 by 3, 9 by 7. Third option is 5 by 3, 7 by 5, and 9 by 7. And the fourth option is 5 by 3, 7 by 5, and then 7 by 5. These are the options. Now the solution. This is given the atomicity, gamma equal to Cp upon Cv, and we know that gamma equal to 1 plus 2 upon F. The three gases are given here: hydrogen, helium, and another ideal diatomic gas. Condition what is? That whose molecules are not rigid but have an additional vibrational mode. So, for hydrogen, F is equal to your 5. Diatomic gas has the degrees of freedom equal to 5. So, gamma is equal to 1 plus 2 upon 5. This is equal to 7 upon 5. Now then for helium is a monatomic gas. All the inert gases are monatomic, and for monatomic the value of F is equal to 3. So gamma equal to 1 plus 2 upon 3. So this is now your 5 by 3. And now for given ideal gas, now degree of freedom will be how much? This is given one the vibrational mode, 3 translational, 2 rotational, and 2 vibrational. When the temperature is very high, then there is the vibrational motion. Vibrational motion can have 2 modes. Either this is along the axis or perpendicular to the axis. Suppose this is the atom, then this can vibrate like this, or this can vibrate like this. So perpendicular, it may be like this or like this or like this anyway, but it will have only 2 maximum degrees of freedom of vibration. So for this F is equal to, now this is 3 translational, 2 rotational, 2 vibrational, so this is totally equal to 7. So gamma equal to 1 plus 2 upon 7. So this is your 9 upon 7. Though at ordinary temperature the vibrational energy, the vibrational mode is not taken, but if the temperature is more than the room temperature, then we take it to be now 1. But this also depends upon the structure of the gas, structure of the molecule. Suppose we have a polyatomic gas, suppose carbon dioxide. In this case, if the array of the atoms is linear, then it will have the degree of freedom somewhat different. But if it is not triangular shape, then it will be not different. So taking into account the structure of the molecule, the degrees of freedom changes. So according to this one, we will have the right option 7 by 5, 7 by 5, 5 by 3, and 7 by 9 by 7. 7 by 5, 5 by 3, and 9 by 7. This is only the right option, second. So our answer is what? Our answer is second. 7 by 5, 5 by 3, and 9 by 7. 9 by 7. Now question number 10. The main scale of vernier calipers. Main scale of vernier calipers. Vernier calipers has n division percent. Has n division per centimeter. N division per centimeter. N division of vernier scale. The n division of vernier scale कौन साइड में n-1 divisions of main scale The least count of vernier calipers is vernier calipers is, now your option is 1 upon n into n plus 1, second 1 upon n plus 1 into n minus 1, third is 1 upon n, and fourth is 1 upon n square. This is so much is the centimeter. Now solve. I will tell you the two methods of finding this least count of the vernier calipers. First, you see, least count is equal to value of one division of main scale upon number of divisions of vernier scale. This is the formula. Value of one division of main scale upon number of divisions on the vernier scale. This is giving that vernier scale. Main scale has n divisions per centimeter, n divisions of the vernier scale. It means vernier scale has n divisions. So what we have? This is not direct. Least count equal to, now what is given? N division per centimeter. It means that 1 centimeter equal to n division. So 1 division value will be 1 by n centimeter. 1 division value of main scale, that is equal to 1 by n upon total number of divisions of the vernier scale is n. This is n. So this is equal to what? 1 upon n square. This is now one way to find the least count of the vernier scale. Now its alternative is what? This is given that n division of vernier scale equal to n minus 1 division of the main scale. So we let value of one division of vernier scale is equal to B, and let the value of one division of main scale is equal to S. So what we have? This is given that n into Vernier scale V equal to n minus 1 into S. N minus 1 division of main scale. So this is NV equal to NS minus S, or this S equal to NS minus NV, or this will give you that this S equal to N into S minus V, or S minus V equal to S upon N. So this is what the value of one division of, and the difference of value of one division of the Vernier scale, that is equal to S upon N. From this formula we are getting it. So actually what we have, the least count equal to S minus B upon total number of divisions. Total number of divisions. So this is your S upon N upon N. And the main scale. Main scale has n division per centimeter. So value of one division equal to 1 by n. So this is equal to S minus B. This is equal to S upon N. This is again coming to this value. Value of one division of main scale upon number of divisions. So this is equal to S is equal to 1 upon N. 1 upon N equal to N. So what will you have? Least count is equal to 1 upon N. So this is what that we have written here. So also we defined that the difference of one division of main scale to the one division of Vernier scale is equal to the least count of the Vernier calipers. So by that we can also find this formula, this like this, or you can do it directly. Value of one division of the main scale, that is equal to 1 upon N, and the value of division of the Vernier scale, so that is now N, so this is now 1 upon N square. So there are two methods are here. So our answer is what? This is now your fourth. You can see the fourth answer. This is now 1 upon N square. Now question number 11. A person traveling in a straight line. A person traveling in a straight line moves with constant velocity v for certain distance x and with constant velocity v2 constant velocity v2 for next equal distance, for next equal distance, the average velocity v is given. The average velocity v is given by relation. Now first is b equal to square root of b1 b2, and second option is 1 upon b equal to 1 upon b1 plus 1 upon b2, and third option is 2 upon b equal to 1 upon b1 plus 1 upon b2, and now fourth option this is b upon 2 equal to b1 plus b2 upon 2. This is the given options. Solution. What is given? The person is moving in a straight line with a constant velocity v1 for certain distance x and with constant velocity v2 for next equal distance. This is given like this. This is now so. This is A, B and C. Now here this is not distance given is x, and this distance is also x. Here the speed is b1, here the speed is b2. This is given to us. Now we have to find the average velocity. Average velocity. Velocity equal to total distance upon total time. This is the formula of average velocity. So total distance is given to here. This is now your x plus x upon the time from here. This suppose a to b the time is t1 and b to c is the time t2. So this is given to you 2x upon t1 plus t2. T1 is what? T1 is the time from A to B, where T1 time from A to B, T2 equal to time from B to C. Now this is the average velocity V. Now we are not given the value of T1, so that you will find from here. This V equal to 2x upon T1 equal to, now this x upon B1. T2 equal to x upon B2. Distance upon velocity. So this is 2x upon. Now we take x common here. This is now 1 upon B1 plus 1 upon B2. X will cancel. This is now your V. Now see the options. What is given? The 2 is coming here and nowhere else. So we keep these two terms on this side, left side, and this we take in the denominator. Then we can have this 1 upon B1 plus 1 upon B2 equal to 2 upon B. B1 and B2 here, and this in the denominator. So 1 upon B1 plus 1 upon B2 equal to 2 upon B. So our option is this one, third. This is the correct option. Answer is third one. So this is a direct application of that distance, velocity and time I take question number 12. Assuming that gravitational potential energy potential energy of an object at infinity is zero. The change in potential energy, the change in potential energy. This is now your final minus initial potential energy of an object of mass m, of an object of mass m when taken to height h to height h from surface surface of earth of radius r is given by first option is gmm upon r plus h, and second is minus gmm upon r plus h, and third is gmmh upon r into r plus h, and fourth option is mgh. Now solution to this question. This has been solved, I think, 2-3 times. Assume that gravitational potential energy of an object at infinity is zero. The change in potential energy, this is he has given final minus initial. You have to find the final minus initial. So final gravitational energy minus initial gravitational potential energy of an object of mass m when taken to the height h from the surface of earth of radius r is given by. Now in this, what the options are given here, the capital M corresponds to the mass of earth. So this is now your earth. This is now radius or center. This is now radius, and this is taken to this much. This is now radius r, This is now height h, so much. So this is now earth. So now here the energy is equal to, suppose, u naught. Here the energy is u. So delta u equal to u minus u naught. Final minus initial. Final is minus g m upon r plus h, minus g m upon r. This is on the earth surface. So this is equal to minus g m upon r plus h plus g m upon r. Now you take common. What we take common? This is now you g m. This is minus 1 upon r plus h plus 1 upon r. So this is you g m into, this is minus r plus h upon r into r plus h. We take the LCM. This r and r will cancel. So here will be equal to g m h upon r into r plus h. This is so much. And now find the option. This is now right option. G n h upon r into r plus h. So our correct option is third. This is not correct option. Now question number 13. 1 gram of water volume 1 centimeter cube. 1 gram of water of volume 1 centimeter cube at 100 degrees Celsius is converted into steam at same temperature. At same temperature under normal atmospheric pressure. Under normal atmospheric pressure. The value is given here. 1 into 10 to the power 5 Pascal. The volume of steam formed. The volume of steam formed equal to 1671 centimeter cube is equal to if the specific latent heat of vaporization, if the specific latent heat of vaporization of water is 2256 joule per gram. Joule per gram. The change in internal energy. The change in internal energy is now your options. First option is 2256 joule. Second is 2423 joule. And now third is 2089 joule. And fourth is 167 joule. This is given. So this is the problem of related with the change of state. So the water is being converted into the vapor. This is already given that the 1 gram of water has the volume so and so at 100 degrees Celsius. So this 100 degrees Celsius is to be converted into 100 degrees Celsius of vapor. So you are given the change in volume, you are given the change in state of the this water. So and you have to find the change in internal energy, because whenever there is change of state, then there is change of internal energy only when something is given here. So using the first law of thermodynamics, using first law of thermodynamics, delta Q equal to du plus delta W, or this delta Q, this is now NL equal to du plus this is now your P delta V, or du is equal to ml minus P delta V. Right? Now put the value. M is given to you now 1 gram. 1 gram. L is given to be 2256. This is not joule per gram, so no need to change this gram into kilogram, because this is also given for per gram. Minus P. P is 1 into 10 to the power 5. Volume 1671 minus 1. But this should be remembered that this volume is given in centimeter cube. That you have to convert in the meter cube, because this is given in Pascal, the SI unit. So this should be multiplied by 10 to the power minus 6. So this is not 2256 minus, now this will cancel. Here this will be now 1670 into 10 to the power minus 1. This will cancel by this one. So this you subtract. This is now your 9, and this is now your 14. This is now your 8. This is 1, 11. So this is now your now 1 and 1 0. This is now your so much. So 2089. Now this is so much joule. Right option is third. This is not right option. So how to find that which law is to be applied and which formula is to be applied. Then you see here that there is change of state, so we go to the value in the chapter of thermodynamics. There we study about the first law of thermodynamics, and you have to find the change in internal energy. You are given the latent heat of vaporization. Also there is a change in volume, so it means that there will be burden against the pressure. So this find P delta V. This is like this. And then calculate. And then this you will remember in that this volume is given in centimeter cube. That you have to convert into the meter cube. Then you find the answer. So this is what the question number 13. Now I take the question number 14. Question number 14. Angular width of central maximum. Angular width of central maximum in Fraunhofer diffraction. In Fraunhofer diffraction. Fraunhofer diffraction. For lambda equal to 6000 angstrom is theta naught. When same slit is illuminated, is illuminated by another monochromatic light. The angular width decreases by the angular width decreases by 30%. The wavelength of this light is number 1 420 angstrom, second 1800 angstrom, third 4200 angstrom, and fourth is 6000 angstrom. Now solution. As you read the question, you will find that this is the Fraunhofer diffraction and there is only the central maximum. And for central maximum, theta naught is equal to 2 lambda upon a. This we know. This so much is the angular width. And now what is given here? One more thing to understand is that width decreases by 30%. This is to be understood. By 30%. means that you have to reduce the width by 30%. It means the remaining will be 70%. So 30% has gone away. Now the remaining intensity is 30% only. Only 100 minus 30, so 70% only. If this is given decreases by 30%, that you subtract this value from the initial value. That will be decreases by. If suppose this would have given decreases to 30%, decreases to 30%, in place of by we write down to 30%. It means that now the intensity remaining is only 30%. 70% has gone away. So only intensity is 30%. This should be kept in mind. By and to. When we say by, you have to decrease it from the initial value. When we say decreases to, this means that this is what that has been left remaining as not appearing. So what we have, that this theta naught dash equal to 2 lambda dash upon it. Second is not so much. So theta dash will be how much? Theta naught dash equal to theta naught minus 30% of theta naught. So this is now your 70% of theta naught. So this is equal to 0.7 theta naught. This is what given here. If this would have given decreases to 30%, then we take only the 30%. So instead of 70, there will be 30%. So now you put these values. Theta naught dash upon theta naught is equal to lambda dash upon lambda. So theta naught dash, this is equal to 0.7 theta naught upon theta naught equal to lambda dash. This is now giving you 6000 angstrom. So this will cancel. Now multiply to this one. So this lambda dash equal to 4200. So much angstrom. 0.7 by this one, 42, 2 zeros are left. So this lambda dash will be 4200 angstrom. Now match the answer. This is given the third one. So our answer is third. This is not correct answer. So you have to understand what I told you earlier also, that sometimes what is given in the language of the question, we do not understand it and we choose the correct or the incorrect meaning of the language. So this is what the meaning of decreases to and decreases by. Whenever you are given the decreases or increases by, the by is given, then just you add. If decreases, then take minus, if increases, then take plus here. If it is given decreases to or increases to, it means that only this so much value is left. So this is what the difference to understand the language of the question. Now question number 15. Burden of a photosensitive material. Burden work function. Work function of a photosensitive material is material is 4.0 electron volt. The longest wavelength of light. The wavelength of light that can cause electron emission. Electron emission from substance. Is now since approximately, this is given approximately. And now option are here. First is 310 nanometer. Second 3100 nanometer. And third is 966 nanometer. And fourth is 31 nanometer. Now solution to this question. Here given the work function, the frequency corresponding to work function is called the threshold frequency. This is the minimum frequency. When frequency is minimum means the wavelength is maximum or the longest wavelength. So whatever wavelength we find corresponding to the work function, that is the longest wavelength that will emit the electrons from the photosensitive material. So this has to be keep in mind that threshold frequency is the minimum frequency or maximum wavelength. So work function. Phi equal to h nu naught. So this is now hc upon lambda naught. This is now phi. So here this lambda naught equal to hc upon phi. Now since this is given in electron volt, so you directly have the formula from this one. This is your 12,400 upon 5 in electron volt, then you will get it in angstrom. So this has to keep in mind that when we are giving like this, then you have to use this formula directly, otherwise this will be having large calculation. So 12,400 upon 5 is given to be 0.4 and 4.0. So this is now 4. This is now so much angstrom. This is now your 43100. Now you see that all the answers are given in the nanometer. So you have to convert this into the nanometer. This is how. This is now your 10 to the power minus 10. So 310 into 10 to the power minus 9. Remove 10 from this one. So this is 310 nanometer. So this is 310 nanometer, this is now first. So our answer is first. So this is what the question number 15 of this series that I have told you now. And students, I also tell you that what is the meaning of the language of the question. This is must. So I again tell you that first to try to understand the language and then you think that what formula, what law will be applied for the solution of the given question. Thank you very much.